is like,
What?
each quarter is like
I thought what we're doing is quarters, right?
No, quarter's 10.
What we're doing is 10 weeks.
It's 10 weeks in the final 3.
Oh,
nice.
So take 2 quarters.
can't you also make
all going to the
it boils all the aromatics
I was like,
on top of your 10 weeks.
We have 2 weeks of final. Oh, but you're at
I
it.
was like, all right, so we get home.
It's super fuzzy.
Well, you get more break, right?
Let's just say,
There's more break in a semester.
let's just all
you
agree
add
that
work in a quarter. It depends on what your goal is.
I'm trying.
So imagine that's where.
Yeah, that's pretty much the whole stuff from rotting. What, you ever bring it to a boil, you're boiling it.
Yeah, exactly.
You rot at a low temperature.
Okay. So, non-homogeneous is just when we have something else. It could be even a constant on the right, but some other function other than 0. So non-homogeneous, nth order, linear would be y, nth derivative, p sub 1x, y, n minus 1, dot, dot, dot. Y prime, p sub n of x and y equals all of a sudden some function over there, okay, non-zero. This section is the first that I'm not really thrilled with the book, but they have a little blurb on this, okay? So the general solution to this, it very heavily depends on solutions to the associated homogeneous equation. So we spent a lot of time on how to find solutions to that, especially when it's linear or constant coefficients. So if we've done the work there, it's just a small step up to finding the general solution to the original non-homogeneous equation. Okay? So the general solution to it is, we'll define this in a second, y sub c, that's what they call the complementary function. But what y sub c is that linear combination of all the solutions to the homogeneous equation. So y sub 1, c sub 1 y1 plus c2 y2 plus c sub n y sub n plus y sub p. This is what the book calls, and I don't remember hearing this, I remember this term before, but the complementary function.
And they use like capital Y to denote this new term.
It just represents this, the general solution to the homogeneous equation is what it is. So general solution to the associated homogeneous equation. And y sub p, p is for particular, if somehow by magic we have one single particular solution to the original non-homogeneous equation. I tack that on to the general solution of the homogeneous equation. So that's the particular function is what they call it. Particular solution to the original if we started off with a non-homogeneous equation.
Like it. Oh.
Okay. So to break this down and just what it says, so if we start off with this equation, it's not homogeneous. Now, we take its associated homogeneous equation, drop that and put 0. If I can find the linearly independent solutions to that, and magically I know one solution to the non-homogeneous, the original equation, then I just tack that on at the end, and that forms the general solution to the homogeneous one. They go through a little bit of a proof of it kind of hard to follow. So if we can find those n solutions, to the associated homogeneous equation, and either by inspection or whatever falls into our lap, and we happen to know one particular solution.
You pull it up.
Now, so all I do is we just tack it on. Okay. So we just tack on that one. They go through a proof of why that satisfies the original equations. It's kind of interesting, but anyway, so there we have it. Now, one thing that this doesn't tell us, this theorem that they throw in the back of the section, one thing that it doesn't tell us is how we find a particular solution to this equation. So even in the examples at this stage, they just say, oh, it's easy to verify that this is a solution to this differential equation. Then it says find these solutions to the homogeneous equation and build general solutions to the original non-homogeneous one. So, inspection, or they hand it to you, we're just going to be verifying. Okay, we'll build up to it, I think. All right, so get some practice. It's kind of why I rushed through this. I want to get you guys working on some problems, and I do have the exams. Those are coming back today.
How did we do?
Pretty good.
On top of your badge, I've got like median.
I don't know what the median score was.
Yeah, the mode.
Here we are.
One more?
Oh, sure.
Yeah.
Oh, okay, right here.
Hannah is here. Oh,
In part B, it says, try, if you want to do this, try to state the answers. We did an example where we had the hyperbolic sine and cosine, which some people pronounce cosh and cinch. I don't feel right about saying that, but they're defined down below. We did an example like that, but not important. If you could write the general solution in terms of whatever, e to the x, and e to the negative x, you're accommodating.
what do you call it? Hyperbolic cosine and cosine.
I try and say the hyperbolic sine cosine.
Squeeze them on.
And number two, yeah, I like this one because there are initial conditions as well. So you're not just looking for the general solution of this, you're going to be looking for the one unique function that not only satisfies that, but also meets both of those conditions as well. And see that hopefully you get one solution. Yeah, this is the one I was thinking of. It's evident. Sure, if they gave that to you, you could say, oh yeah, that works, because y double prime is 0. It's 4 times 0.
The cosine and sine to it, is that not specific, or is that a general, like, based on what we've been doing?
Oh, they probably
This
use,
is based on,
now, so the way you find a complementary function is drop the non-homogeneous part and put in, you know, y equals e to the rx, solve the characteristic equation. Now, might end up being might end up being the complex roots. But remember, boil it down, you still get
It's
the
not
C1
necessarily a
sign.
universal sub.
Yeah. And I don't know if you'll have,
I'm sure of something, so it's R squared is plus or minus 2. According to the superior of that. Or it could be or it's be positive, or it's negative.
Why is that? You got the steep, whereas R squared equals 4. Oh, careful. R squared equals 4, so R equals
Yeah.
and so those are distinct roots. You're gonna get e to the negative 2x. Because negative 2 is a solution for R, and you're assuming the form y equals e to r x. So you get R equals negative 2, your solution is negative 2x. Right? The other one is positive 2, e to the positive 2x. So those are two solutions.
But how do we know that, what's the stop it from so?
Oh.
Because this is, so if you, right, this factor of R squared minus 1 equals 0, this factor is R plus 2R. So both of those roots are multiplicity. And you get negative 2 multiplicity 1.
So
2 multiplicity 1, so you wouldn't worry, you wouldn't tack on that.
Okay, I was wondering if that was the case, would this actually be the same?
So, and that only happens, with the relativity. So say for instance,
I don't know.
Yeah.
say you had, the 2 was a repeated root. So you have R squared equals 2, you have C1 equal 2x, C2 e to 2x, but then you only be able to the negative 2x, so you can just C2, C3 e to the negative.
Oh, right.
Only associated with the repeating the time on the extra term.
Yeah.
That's an extra linear factor. Yeah. Oh yeah, try it out. Now it's gonna be sine h cosine h of 3x and negative 3x. Wait, what? Your solution to this is plus or minus 3.
Yeah.
So your solution, oh, to negative 3x. Yeah, and that's gonna be over the form, so cosh 3x. And sinh 3x.
So you're saying, how can we tell that it's going to be quotient and sinh?
I'm just saying, because in this case, you got opposite, because you got opposite roots, negative 3 to 3, and in the form of these hyperbolic functions, the x and the negative x. If you plug in e to the, or sorry, if you plug in 2x in the argument, you get e to the 2x, e to the 2. In this case, you got 3, so there's going to be some 3x. You can,
Because we can.
yeah, because you can't, it's not necessary, so.
So basically, that was one of the things of the theorem is that anytime you have, that it happens to be a definition of a hyperbolic.
Yeah, because these are just, basically, these are linear combinations of e to the x and e to the negative x. Same thing with this, I got a minus in between, so it just says that, okay. And in this case, if it's e to 3x and negative 3x, it's going to be parentheses, cosh 3x, and 3x, and find the appropriate linear combination of that, which that would represent linear combination. Yeah, I mean, it's not necessary, it's just that, oh yeah, you could do that.
Yeah, don't turn away.
That's for the first one, but for the second one, you can put a 3 in front of it.
So it's essentially it's e to the plus.
Yeah, so try and find a solution first.
Yeah.
Find a solution to e to
What am I supposed to
3.
remember?
And, is that a negative 3? So,
So we could
you might notice that you got
we
argument,
could say that
3x.
pull that
up there.
C1 plus
So
C2,
what I'll
pull
do
the e to
is,
the
if you write
So we can pull the C1
3x, it would be e to the plus e to the negative, you know.
Yeah, look in the book, there's your.
And you can sort of massage a coefficient, you could call this
Just ask him.
plus e times times sinh, whatever, 2x, you might be able to find coefficients A and B in terms of C1 and C2 that allow you to write it as some kind of combination of these.
Damn, the answer.
It's not necessary.
Damn.
It just shows you that you can do things like that. Since these guys are just linear combinations of 2 to 3x.
Why is it over 2?
You can massage the coefficients around and make it look like that for some appropriate coefficients. Yeah.
That doesn't make sense. That'd be this one, right?
3R. Oh, is it? So you get 3 and negative 3. So in other words, the solution to this curve would be general solution would be any coefficient equal to 3x plus any coefficient equal to negative 3x. So
what do you use this one?
yeah, it says to state the answer in terms of the hyperbolic functions, but let's see if this is the same thing. So 2 and cos 3x would be.
That is x. Is it in terms of x, right? Yeah. it's just-
Now you get e to the 3x plus e to the negative 3x over 2. Those cancel out. Oh, and you get particular ones, but basically it's going to be